molecular science immediately obvious talk with our very own Keita here. So I'm going to go ahead and do a brief introduction, then we'll go ahead and get started. So for those of you who don't know, this event is about the complexities of the molecular world. And how virtual reality allows us to understand and manipulate models of this molecular world to understand. A little background about Keita here. He's actually won 2 state championships at robotics competitions as the lead programmer. He's won awards for filmmaking, and he was named San Diego Surf Festival's Emerging Filmmaker. He has a bachelor's in management science from United States, San Diego. I'm really excited for this talk. Throw some hearts if all of you are excited from this talk as well. Yeah, awesome. All right, Keita, whenever you're ready, the stage is yours.
Perfect. Yeah, great. So I like walking around, so I'm just going to walk around like this. Hope everybody can see the talk. So I'm going to go ahead and get started. So, this is pretty obvious, and many of you probably know this, but...
I'm going to pause you very quick. You're going to want to amplify your voice before we go any further.
Sorry, totally forgot. There you go. All right. Everybody should be able to hear me now. So this is pretty obvious, and everybody probably knows this, but in the 16th century, there was this little-known invention called the microscope, and the microscope was a pretty big deal in science, right? From the fact that we learned about microorganisms to the DNA, which was, essentially a result of a later iteration of the microscope. The microscope really brought a huge amount of scientific innovation into our world. So from this, we know that scientific visualization drives scientific insight. So visualization is a critical part in understanding science. But what's funny is that the microscope was actually mainly a toy when it was first invented for rich homes. And so many people don't know this. And what's even more interesting is that I think 5 centuries later, we see a similar trend happening with virtual reality, where, virtual reality headsets have come down in prices, but $400 is still quite expensive. And back in 2015, 2016, it took about $2,000 to $3,000 to get started with a VR headset. So you could argue that, combined with the gaming focus, that virtual reality also started off as mainly as a toy for rich people. And so if you look at the future of scientific visualization, we all know what it's supposed to look like, right? From Star Trek to Iron Man, we've all seen that kind of sci-fi hologram where you can hold molecules in your hands, you can look at the periodic table, that's floating right in front of you. The sci-fi future that we've all thought about and dreamt about, we all know what it looks like. And so that's what we made. So Nanome is a visualization and modeling tool, mainly for molecular data and molecular design. And it's all collaborative, so you can be right next to your colleagues, just like here in AltSpace in virtual reality. So our main business, we're a company, we started this in about 2015, 2016. Our main business is servicing advanced scientific research within kind of industrial use cases, whether that's big pharma or chemical engineering or things like that. These highly specialized fields are often referred to as computational chemistry, structural biology, medicinal chemistry, even computational nanosciences, which all sounds like really kind of daunting and complex. The problem with that complexity is that it usually takes somebody with a PhD or master's in that scientific field, and on top of that, they need a pretty solid understanding in programming or scripting, and usually Python or even C++ and Fortran. And so XR, AR and VR, and Nanome changes this. And in fact, it's not just us that are saying that this is the case. We actually wrote a scientific paper with Novartis that was published in the Journal of Molecular Graphics and Modeling, which kind of states that by reducing the barriers to structural data, I think people are waving their hands. I just want to make sure that Everything's good. Yeah. Oh yeah. Hand, heart. Nope. Okay. I'm just gonna continue. Oh wait. Host tools. Panel. Participation. All right. I just want to make sure one hand has been raised.
So just to clarify, Keita, are we doing questions during, or would you like to save questions until the end?
Oh, till the end. I just want to make sure there were no problems.
Oh, nope, I've had no issues. So I'm going to go ahead and turn off hand raises. Please save your questions till the end, and then we'll do all that then.
Okay, great. So basically so it's not just us that are claiming this. We actually wrote a scientific paper with GNF Novartis that kind of outlined how VR and scientific visualization using VR impacts and facilitates science and democratizes these what's usually super complex to be much more accessible to many more people. And so we believe in enabling more people, not just scientists, to leverage powerful scientific tools. And this means, naturally, that education is a core part of our company philosophy. And so some of you might know this, but one of our first prototypes that we built is called CalcFlow. It's actually a 3D visualization, a graphing calculator, if you will. One of our users called it the TI-84 meets Burning Man. And so you could pretty much it's literally that, where you can graph any 3D function in virtual reality. And so there's some other functionalities like being able to do vector fields, double integrals, surface integrals, vector addition and cross product. And by the way, this is kind of the reason why I put the parentheses STEM into my title, just because I am kind of going a little bit off topic of the molecular world. Even though, what's interesting about science and math is that they're often intertwined, right? So we actually did an unofficial study and did kind of a survey with the students about their experience with CalcFlow. We did a few pilots at UC San Diego where we spun out from. And so the blue is the blue is the confidence of understanding of each of these concepts in these graphs before they tried it in VR. And the red is the confidence of these concepts after they learned these concepts in virtual reality. And you can see that, very consistently, whether if it's parameterized surfaces, curve orientation, curve parameterization, line integrals, often very, very complex calculus concepts that are very reliant on three-dimensional understanding, that across the board, students became much more confident in their understanding of these concepts after using virtual reality and CalcFlow. And so, if you kind of look at the study as a whole, 11 out of 12 students actually found that virtual reality and CalcFlow was actually useful. And here are some kind of highlights of the kind of testimonials that we got afterwards, which is that, virtual reality is a vital tool in understanding various math concepts. It's helped visualize the content that they're actually studying. This is my favorite quote, which is this right here at the bottom, talks about how, I've always heard that math is the language of the universe, and seeing how it actually makes up everything in our lives in 3D makes this entire experience enjoyable. So, I'm extremely proud of this, that, we've had students come up to us and actually be able to understand that, math isn't just some complex equation that you see on a chalkboard. It's actually all around us. And VR literally makes it immediately obvious that it's actually all around us. And so why Nano made CalcFlow, right? Our focus is kind of on the molecular world and doing molecular models, but you might ask, why we made this math tool. So as I mentioned earlier—
I'm going to interrupt here very quickly, Keita. So sorry to do this to you. Can you go ahead and get some hearts from people in the crowd who are able to see the slides? If you can see the slides, send up some hearts. Okay, if you can't see slides, please send up some frowny faces. Okay, we do have a few people who can't see the slides. All right, so what I'm going to go ahead and do is ask those of you who can't see the slides to go ahead and open your menu, go to Settings, and click Re-Enter. And then once you hop back in, give me a heart or a frowny face, depending on if you can see the slides or not. But I have to say, this is very interesting. I love the outlook from being able to see it all through VR. It makes a lot more sense now than it did in 8th grade science class.
But, yeah, thank you. Yeah, and I'm sorry about the technical issues here. We can take a pause and
thanks for bearing with us. You guys still aren't able to see the slides. Okay, give me one moment then. I'm going to go ahead and try to refresh the browser. And if for some reason this doesn't work for all of you, I apologize. The slides will be posted as well as videos of the event. But I apologize for the technical.
So I guess I think I could toggle this mute button. So you guys should be able to hear me now. Or no, wait, you guys should be able to talk.
Yep.
Maybe. Okay, I guess never mind.
Yeah, I think we are unmuted. The slides disappeared for me when you showed the like slide 2 or 3 where it was all the different interface clips from the movies. It kind of did a whole bunch of weird resizing. It looked like the browser crashed and then it went black for me.
Got it.
I don't know. Some people can still see it. I don't know if there's any difference between like I'm on a Quest and versus people on Vives and
I see.
stuff like that.
And just because we're waiting to get some technical issues fixed, I'm curious to kind of hear about the audience makeup here. So are you all students or educators or VR content creators? I'm curious. Oh, never mind. I guess we're back. I was just kind of talking with the audience.
I'm back now. So sorry about that.
Yeah, no worries.
I've been having issues with the internet all week. So, are the slides loaded now for people? Did we figure that out?
Oh no, where do you go?
Maybe we just live with it and go for it.
Yeah, and I'm happy to share the slides with you guys. I think I sent it to the event organizers, and anybody could take a look at it. So I guess we'll move on, or I don't know if I should wait for the other presenters. But wait, I'd love to hear from the audience what the makeup is. Is it educators, developers, students?
Who me? All of us?
Yeah, anybody.
Well, pretty much I know a little bit about molecular level, but not a student.
Oh, I got a message from a moderator saying to go ahead, so I'm just gonna go ahead and continue with my presentation. Sorry guys, we can do the discussion afterwards. So anyways, yeah, here are kind of the main reasons why we made CalcFlow. Math and science are intertwined. It was one of our first prototypes. We had a lot of theories about how the interface of science and technology should look like. And we had a bunch of ideas, and it was a great way for us to test, grabbing and scaling, what that feels like, using the joystick, all those types of things in VR that we now take for granted. We were able to test using CalcFlow. And arguably, this is from a XKCD comic, which is that, math is kind of the layer below the atom. And we want to, our whole theme with our company as well as our software is that, everything zoomed down to the molecular and atomic level. And so, we want to see how if we were to go below the atom, then looking at electron orbitals, spherical harmonics, a lot of that stuff is arguably below the atom. So yeah, those are the reasons why we made CalcFlow. And so now more kind of on the molecular side and on Nanome. So Nanome is a molecular design tool in virtual reality. And so you can kind of think of it as like, tilt brush for molecules in virtual reality. You can use this palette on your left-hand controller, which is kind of like, it has like, like different functional groups and stuff like that. And you can modify them and see basic energy minimization so that they show the right structure for a small molecule. But really, it can be extended to several thousand atoms, 50,000 atoms, maybe even 100,000 atoms, depending on the GPU. And you can also simulate those as well. So we have a pretty in-depth plugin system that allows you to connect our software into existing very advanced computational chemistry tools, such as docking and molecular dynamic simulations and things like that. And so you can actually, on the right top corner is a example of a trajectory file that's being played back in virtual reality of more of like a macromolecular scale and opposed to a small molecule scale. And of course, one of the biggest advantages that you get in virtual reality is being able to use your hands intuitively to be able to edit these molecules. So one of my favorite things to do that's super satisfying is just like changing a bond angle with your wrist just by grabbing a part of the molecule. So you can see an example of that on the very right. And so it's not just the fact that you can visualize these like 3D aspects intuitively. It's also that you can have this kind of active learning by doing, by interacting with these molecules. And you can see how after you tweak it, it's not just like this static model. You can apply simulations to see if it actually stays that way. So that's kind of a really great way to be able to learn as you do, like I said. So now kind of more into the educational applications of Nanome. So this is an example of pulling up a PDF file to look at just simple kind of organic molecules within Nanome. So you can literally kind of compare, against a PDF or a JPEG image, how the 3D molecules look like in VR. And of course, the entire periodic table is accessible in Nanome as well. So being able to, like look at the atomic weights, compare them with your students and fellow class members, like things like that becomes very obvious and immediately accessible. And so now kind of going more into the sharing aspect as well as the classroom aspect, how are people using it within the classroom? So here's an example on the left is a kind of a sample of like what students and teachers have done within the classroom using Nanome. So you can see the assignment was to create and modify a certain molecule, and then the students had to take a picture of that and send it to their email. So there's a kind of a 2D camera within Nanome that you can use. You can take a picture of it and then send it to your email so you can share it with your colleagues. So another very powerful thing about Nanome is the macro system. So just like in Excel, every functionality in Nanome can be pre-programmed using Lua, which is a kind of a programming language. And so if you find yourself doing certain kind of functions over and over again, you can pre-program them so that you could just press one button and have it do it for you. But what's really cool is that actually you can use the same system to create kind of guided experiences within Nanome. So kind of the classic example here is a molecular biology class that's learning about DNA transcription, for instance. And so the protein comes to the DNA and then it unwinds it, makes the RNA portion and so on and so forth. All those animations can be made within Nanome. So we've gotten several requests from educational institutions and educational users like, hey, I'm teaching this one class. Could you like make a feature specifically for this class? To be honest, we don't want to make the content for each individual class. We want to let you guys make the content and share it. So one of the things that we're trying to do, you can already create content yourselves, but one of the things that we're working hard on doing is to be able to enable educators to share the content that they make within Nanome, so that then you guys can communicate with each other and collaborate and really take it to the next level, which I think is something that is just traditional education and teachers just was not able to do before in terms of a whole nother level of collaboration of making educational content. So this is actually an exact example of what I just mentioned. So we have a user Slack group called nanomers.slack.com, and here's some kind of examples of our users kind of asking for how to use the software or what kind of existing content there are that could leverage. And so we've been surprised at the amount of kind of different types of users that have been using Nanome. So again, we come from the high-end research side, and so seeing these types of responses like, hey, I teach nurses and paramedics clinical skills, and I want to show them how insulin binds to a certain protein or whatever, right? Being able to show that within Nanome, not just showing it and experiencing it within virtual reality, but also connecting with other teachers and educators to get that content and to iterate on that content to make it even better, something awesome. And actually, on the right there, you see one of the responses that was posted in regards to this question, which is talking about the macro system and willingness to share this different types of educational content. And so kind of beyond the traditional classroom use case is the kind of library use case as well as the research use case. And so we had a university use use Nanome in virtual reality to take like a field trip, if you will, a virtual field trip into the molecular world at a library. And so 15 students were all in the same virtual room together, looking at 3D molecules together. And so that's, it's more of a, I guess, short-term / like one-time only use case. That's not necessarily a everyday classroom use case, but it's still a use case in a sense that it allows, kind of intermediary and beginner type classes to be able to visit the molecular world in a way that was never possible before. And then the second use case here on the right, which is something that I'm extremely excited about, which is just like in AltSpace VR, where you meet strangers and start to collaborate and talk about different topics in VR. We have researchers that actually like meet in VR in Nanome, and they're potentially talking about doing a peer review of each other's research in virtual reality. And so this, in particular, in this example, we have a Australian researcher, university researcher, that's meeting a Swedish researcher, which is, like if you think about it, it's literally across on the other side of the world that they're now meeting and able to collaborate. Again, really hard for me to imagine how this would have happened without virtual reality. And this could extend to not just hardcore research, but also teaching, creating teaching content material as well. So here's kind of another testimonial. It's actually from, I know I blanked out the Australian researcher here, but that's actually him. He does research, but he also teaches biomedical education at the University of Sydney. And he says that, in his 30-odd years of education, that he's never seen so much engagement and wonder among the students of the molecular world in virtual reality, and of course Nanome. So this is really heartwarming to see. But one thing that I saw that I think probably many of you have heard of at these other talks as well, is that students are less shy presenting in virtual reality because they have this avatar system, and they feel like they're more centered around the content than an individual that's presenting about the content, right? So when you have this crazy 3D hologram of a molecule in front of you, that's like the center of attention and less about you as a person presenting the topic. And so that's really it's amazing to see that those barriers are overcome within virtual reality, and students care more about the content itself. which is great to see. And lastly, this kind of goes into the example that, well, this is the kind of reasoning behind the title of our of the talk. And he just actually published a paper about looking at different types of proteins, and he actually cited. So this is our second scientific paper citation. But one of the quotes, we made a video with him. He says that, in VR, his structures became immediately obviously understandable, right? We talk to researchers all the time that said they were so sure that they should have developed a molecule, to the left side, let's say, in 2D, right? And then they look at it in VR, and within seconds, they're like, oh my gosh, I've made an obvious mistake, right? We should have built it this other way, right? And so, again, more on the research side, but, if researchers who are experts at these things are already finding out about these like obvious mistakes in 2D versus virtual reality, I can't imagine that students are going to go back into 2D after they use virtual reality, right? And one of our goals, again, from a company standpoint, is like if students use virtual reality to learn chemistry within our app, then we want them to go to pharmaceutical companies and chemical engineering companies and say, hey, you guys, why don't you guys use virtual reality, right? So that's kind of more on the company side, but still a very exciting thing. So here's kind of a summary of my talk and some key points. Collaboration, just like what we're doing right now within AltSpace VR, that collaboration is a key feature. Students can actively engage with each other and instructors and TAs. And it promotes self-learning, right? It's not just being able to pull up a structure that's static. It's being able to actually reach in and change those things, see the simulation results, and actually understand by doing. And this goes into my last point, is tons of active learning, guided notes, PDFs, PNGs, JPEGs, etc. Student presentations. So, the Australian researcher that I mentioned, he did student presentations. And then the last one is actually really cool, is that in Nanome right now, when you first launch the software, there's a whole featured molecules section, and the featured molecule section includes the latest molecules that researchers have been studying that have been published in scientific papers. Now, obviously, these are on the advanced kind of concept side, but what's really important here is that for me as a student, I always wonder, okay, why am I learning this thing? How does it actually have to do with real life? And the fact that you can connect course material to current active research, I think is something that's very powerful, that can only be done when you have a software that is actually scientifically accurate. So on that very note, I'm super excited to share this with you, which is that one of our research, a different Australian, we have a lot of researchers in Australia that love our stuff, even though we're based in California, but one of our researchers in Australia, actually at a government research lab, is actually using virtual reality and Nanome to study the coronavirus and its structures to ultimately develop a vaccine for the coronavirus. Now, I heard a lot of people coughing in the audience, and around the lobbies and whatnot. So I hope people don't have the coronavirus. But he's actually going to take us through these structures in virtual reality tomorrow at 2 p.m. Pacific time, and we're going to live stream it. So we don't have the same level of kind of infrastructure in terms of like presenting and having an audience like AltSpace does. So we're going to be streaming it from a 2D mode and then onto YouTube. But what's really cool is that we're going to save the workspace, and people will be able to load those structures into virtual reality afterwards. So again, this kind of connects to that active learning part as well. So yeah, it's one of those things where it was complete science fiction of trying to actually develop a vaccine for a epidemic back when we started this software a few years ago. But it's already happening, and the fact that these researchers can come together and collaborate to find a solution for things like this is pretty unbelievable and incredible. So this is kind of my final slide. Thank you so much for listening. I know there are some technical difficulties there, but I appreciate your patience. You can download Nanome for free from SteamVR. We've been trying to get on the Quest store, but Oculus doesn't let us, so you can check out SideQuest. And we're also obviously on Viveport and stuff like that. So check it out, and happy to answer questions.
All right, let's get some hearts and some claps for that amazing presentation we just saw. I apologize for being in and out. I somehow crashed the internet on my side of campus. Anyway, so we're going to go ahead and open up the questions. So in the bottom right, you're going to see a hand show up. If you do have a question,
Yep.
go ahead and click that raise hand button, and we can go ahead and answer some questions. Anybody at all? Anybody have a question? Oh, there we go. We've got our first question
There we
from
go.
Bob right here in the front. There you go, Bob. You've got the microphone.
Hey, everybody. Thanks. That was really great to see. Just wondering, what are the barriers that you've seen to the adoption of your technology and others like it in academic settings for students? Is it, cost, acquisition of hardware, management of the software and tools to make sure everybody's on the same page and not off playing a game? I wonder if you can comment on any of those kind of issues.
Sure. Wait, is my thing working? All right, great. So yeah, it's multifaceted, right? So what we found is that kind of like the least barrier to entry within academia specifically is academia research, because a lot of our feature sets are very focused and dedicated on academic research and less on the actual teaching side. The macro system that I just mentioned, I mean, that's a feature that was just launched later last year. So it's really not been that long since it's launched. And ever since it has been launched, we've seen, a lot of power users that was like, oh yeah, I've always wanted to, build an experience zooming into hemoglobin, right? And how blood carries through. And so, people have made those types of experience since then, which that's kind of the second barrier to entry, is that the educational content, right? Teaching material and seeing how it integrates within the classroom has kind of been a barrier to entry. So a lot of chemistry professors and teachers are extremely excited when they see software like us within the VR stores. But then, the next question is, how can this relate to chapter 3 in this one textbook that I have, right? Or, how, and then, that's one question. The other question is, how can I show my boss that it's going to actually improve student test scores, right? And so it's kind of multifaceted, right? So, the kind of the content side, and then, some basic friendly educational focused features like a student license, for instance, that, like Altspace does a great job at, this whole presentation handoff and the hand raising mode and things like that. We have a similar system with like having one presenter at one time, but it's not as nearly as fleshed out. And so, a lot of teachers request that. I don't think it's necessarily a complete barrier, but it's definitely adding friction. And there are, a lot of teachers are already, fighting an uphill battle when it comes to budget acquisition, as well as, efficacy and things like that. So the fact that, we're not completely student and classroom friendly per se does not help. Although, it's really depends on the class, whether that is, a final point that becomes a barrier or not. And like lastly is the hardware portion, right? Like among the budget that is allocated for this type of solution, we see probably half or less than half of that money, just because, like most of it's spent on hardware, for instance. So that's also another aspect. But yeah, it seems like you're quite familiar with the classroom setting, so you could probably imagine. I think I covered most of the barriers to entry. Oh, well, three more questions.
Yep, so we'll go ahead and let's see who else is next. So Bob, you got yours done. Alejandro, you are up.
Oh, am I giving them microphone or?
No, he should have microphone. Interesting. Alejandro, give me one moment. Apologies, the tech has been all over the place. All right, I'm just going to go ahead and unmute. So Alejandro, if you would come up to the front and go ahead and unmute your microphone, and I will give you megaphone now.
Just wondering if your software can have a side branch with Google quantum computation, so you can do a little bit further investigations.
Yeah, so right now, so we have a very robust plugin system that allows you to interact with kind of offsite compute resources, such as the cloud or supercomputers or whatever. The plugin system right now is reserved for our enterprise customers in kind of pharma and whatnot. We've gotten so much requests from the academia and research side that we do want to open up the plugin system to academics. So that is something that we're actively pursuing and should be available by the end of this year. So it's going to take a little bit of time, but yeah, go ahead.
I know that will be so awesome. The computation will take really fast computation that will take longer for a computer to analyze the whole situation or make simulation about it.
Yeah, definitely.
Yeah, it's a great progress, though.
Fuck you guys, you're all fucking stupid niggers.
Anyway.
Sorry about that. He's gone.
Sorry about that.
But yeah, thank you. That was a great answer anyway. I'm looking for you guys.
Yeah, if you go to docs.nanome.ai, that's our documentation page, and it has like a whole plugin list and whatnot as well. So we're going to be trying to open up the plugin system.
All right, that's awesome. Thank you.
Great.
I think we're still having problems. Maybe Shaz?
Yeah, I think we're having some background issues here. So I've turned off mute all. So if all of you want to come down to the front here to ask any questions, if you don't have any questions, I would encourage you to go out this exit door the way that I'm facing to the globe, take a left, and that's to the social space. And you can continue questions and stuff there as well if you'd like.
Awesome. Hey, thanks so much, man.
Yeah, again,
High five.
so sorry for
I guess you're on 2D. I forgot.
I'm a 2D, I
I'll
can't,
just-
sorry. But,
All right.
go. How
Well,
about
thanks
this?
so
There you
much.
go, high five.
Oh yeah, there you
Yeah,
go. Woohoo, yeah. Okay.
All
Real
right.
quick, some people were asking about the slides availability. I think you guys are going to make them available, right?
Yes, so the recordings of all of the events are going to be posted on YouTube by the end of the week. We're also putting them up in our Discord channel, which will be which is available for people to pop in and read. Go to educatorsinvr.com, and you should be able to get access to basically everything at this event, at least to see it.
Perfect.
And
Awesome.
if you have any questions for me, stick around. But I think Keita is going to go ahead over to the social space, and if you want to continue any questions over there, I encourage it greatly.
Hey, Shaz.
So
Excuse
again,
me.
so sorry for all of the
Hey, oops, sorry.
technical issues.
You didn't happen to get that fella's name, did you?
Which one?
The one that come down front and had some choice words. You
Oh
didn't?
no, I don't.
I wish I knew.
Yeah,
I'm
sorry.
sitting here in mod. I mean, he popped up right in front of me, so there wasn't nothing I could do about it. But
Yeah. No worries, no worries. I'm used to the internet.
I hear you.
Camera VR.
All
And
right.
if you
So
ever
yeah.
want to ask questions, the transporter is right out here,
Okay, what's going on in
right
here?
up